Hey everyone, this is Mayur. Welcome to ML Works. In this video, we'll be comparing Pandas with CuDF and try to understand the performance difference between these two libraries. The major difference between these two libraries is that Pandas runs on top of CPU while the CuDF requires GPU to be present to run any data analysis task. With that, what we'll do is I have a notebook currently hosted in Google Colab and it is connected to a T4 instance, which is nothing but NVIDIA T4 GPU, and then we'll be running a bunch of tasks. We'll load a data set and then we'll perform some operations with like merging, drop, concatenation, reverse the columns of a particular data frame, and we'll try to compute the time taken for each of these tasks and plot the graph, and we'll understand which is better in terms of time taken to perform a particular data analysis task. Okay, so with that, what we'll do is first we'll just look at our GPU using NVIDIA SMI, and we'll notice that it is a Tesla T4 and it has around 16 GB of VRAM. And then we'll be cloning the repository of Rapids AI, and then we'll be running this particular command to install the CuDF. And probably in this notebook it is already up and running, so we don't have to, it won't take much time. So once that is done, we'll be importing the packages of Pandas, which are crucial packages: Pandas, CuDF, and TimeIt. This is for calculating the time taken for a particular task. So let us import these packages. And here I have file list. Okay, these are 5 different tasks that we will be trying to capture the performance of. First is reading the CSV file. We'll be first doing it for CuDF, followed by Pandas for reading CSV. Then we'll perform reverse operation, reversing the column names. Or then we'll do concatenation, drop, merge. We'll be appending the time taken for each of these tasks and put it into each of this list. Now, just to talk about the data set here, if you look at here, I have this roadtrail.txt file, which is the data set. Here I have, which is around 80 megabytes, around 78.44 megabytes. Okay. Now, let's talk about each of these functions that I've created here. First is display time. So after you run an execution, a task, or run a function, you will get this message: what was the function and what was the time taken to run that particular task or a function. So let me run this function. Then here we have get read CSV. Here we'll import the package, import the data set either using Pandas. If you give pass method as df, okay, then it will be pandas.readCSV. If the method is CuDF, it will be CuDF is used for reading the CSV. Next we have get reverse. So you will be passing a data frame here, and you will be swapping the reverse or reversing the columns. Okay, and that will take some time actually in the backend. So this is the function for that. And here we have 2 data frames which will be merged, okay, and on a particular column name, based on a particular column name, and we'll do an inner join kind of thing. So let's run this function here as well. And then we have get drop. We'll be dropping a column based on axis, and that's the whole operation of this function. And here we'll concatenate 2 data frames again, and if you pass CuDF, if by default it is CuDF, if it is method is df, then it will be doing pandas concatenation. Now let's load the file, which is roadtrail.txt, and each of these operations which I mentioned here, get read CSV, reverse, merge, drop, and concatenate, it will be repeated 10 times, and we'll get a better understanding of the performance when this is running in the backend. Okay, that's why we are repeating each of this operation 10 times and we are timing it. So let's run this cell, and here first thing is CuDF CSV read timeIt. We want to repeat this 10 times and we want to read the CSV file, and this is global. Here we have given this parameter. And next what we do is, once this is executed, we'll get the total time taken by this particular function, which is get read CSV, and it will be stored into read CSV list. And here we are also storing the data result of this particular read CSV into another data frame here. Okay. Now let us run this one. We'll see CuDF read CSV has taken less than 1 second to read the CSV file, which is for around 10 times, okay, and of 80 MB megabytes. Okay, it took on around 1 second. Now the same CSV file, which is the text file, about 80 MB, when you repeat for 10 times using pandas, it takes around a huge amount of time when compared against CuDF. So if you look at the time taken by pandas to read the CSV file 10 times, it is 26.8 seconds. The same CSV file read by CuDF, it took less than 1 second. Next is reverse. Again the same functionality. We call the same function get reverse. We repeat the 10 times and capture the performance, the time taken, and then we append the result into reverse.list, and we store the result of the get reverse into relation to CuDF. Now it takes around less than 0.008 seconds, 0.008 seconds. Now if we do the same operations of reverse in pandas, let us see how long it takes. It took 2.3 seconds. It took less than 0.008 seconds. Okay, there's a huge difference. Now coming to merge operation, what we do here is we pass those two CuDF, whatever we got here, relation 1 CuDF and relation 2 CuDF. We pass these two data frames and pass it to CuDF merge underscore df. Here we pass those two data frames and merge those data frames on a particular column. Now let us see the time taken for the merge part. It took less than 1 second for merging two data frames of huge size, about 80 MB. Okay, now let's do the same thing using pandas. And this will take a lot of time, I'm quite sure about that, because pandas is generally slow when it comes to these kind of operations. So let us wait for that. It took around exactly 1 minute to combine these two data frames. So if you compare this against what CuDF was taking, it was less than 1 second and it took around 60 seconds. Now let's do get drop on particular using CuDF. So we are also again repeating it 10 times, and let us run this one. The time taken for this, it is 1.1 seconds, and if you do the same operation using pandas, so it takes around almost 100 seconds to drop rows from your particular data frame in pandas. So next what we'll look at is concatenation of two data frames. One is relation 1 CuDF, relation 2 CuDF, and we'll try to concatenate using CuDF dot concatenate, and similarly pandas pd dot concatenate. Okay. And if we look at the time taken by these two operations, so it took less than 1 second, it is less than zero point 0.1 second, and when it comes to pandas, it took around 4 seconds. Now, what we'll do is we'll try to plot these times, since we have done around 10 operations. We'll try to plot each of those. So let me import matplotlib. First, what we'll do is we'll plot read CSV to understand the time taken. So if we look at the graph here, for reading the CSV, the first line is this particular line, that less than 5, what we see in the blue color point, is for CuDF. And on the other hand, we have this for pandas, which took around 27 seconds. And it took less than 2 seconds or 1 second, I guess. And for drop operation, if we look at the time taken, so for drop, it took almost 100 seconds for pandas, while it took less than 2 or 3 seconds for CuDF. And if we look at the merge operation, so it goes again, it took around 60 seconds for merging two pandas data frame, while it took less than 2 or 3 seconds for combining two CuDF data frames. and next the concatenation operation and the reverse operation. So if we look at the concatenation operation, it took less than 0.5 second for CUDA-DF, and for pandas it took around 4 seconds. And when it comes to reverse, it took less than, I'm not even sure what is the point. It is 0.008, I guess, and it took around 2.3 or 2.4 seconds here for pandas data frame. Now, in terms of time taken, right, how many x CUDA is faster than pandas? Let us understand this using this particular cell. So if we, I'm running all these cells, okay. So if we see here, CUDA DF is around 29.09 seconds times, not seconds, 29 times faster than pandas while reading the CSV, and it is almost 300 times faster than pandas while reversing the CSV columns, and it is around 66 times faster than pandas while merging the two data frames, and it is 44 times faster than pandas. CUDA-DF is 44 times faster than pandas while concatenating the two data frames. Now, when it comes to dropping the records from your particular data frame, it is 85 times faster than pandas. So there is a huge difference when you use CUDA-DF compared against pandas. So if we go below, this is just the code for downloading the data set, importing the package, and turning that into a proper data set which we can use for data analysis. So what we have understood from this particular video or from this particular notebook is that CUDA DF is widely performant or immensely performant compared against pandas, and it is highly recommended. If you have a GPU, the data analysis should be done on GPU while compared against pandas based library which uses CPU, because the number of cores that is available in particularly for GPU is thousands of cores are available for you to perform these operations, while CPU has only limited number of cores. And especially when you have a larger data set, it makes sense to use CUDA DF than to use pandas. With that, I'll be concluding this video. Thank you so much.